1 to 10 billion humanoid robots per year. That's not a science fiction premise, that's the production target Elon Musk just announced. And to get there, Tesla built something that doesn't exist anywhere else on Earth. A chip factory designed from the ground up to make robot brains. Every humanoid robot being built today runs on chips designed for something else. Figure AI uses NVIDIA hardware built for data centers. Unitree runs Qualcomm silicon designed for smartphones. These chips work, but they weren't designed for what a humanoid actually does. A walking robot makes hundreds of decisions per second. Where to place a foot, how hard to grip, whether that shadow is a step or a fall. Each decision is a neural network inference, and each inference burns power. Here's the problem. A robot has a fixed battery. Every watt the processor consumes is a watt not available for the motors that make it move. Off-the-shelf chips are power-hungry because they were designed for devices plugged into walls or vehicles with massive batteries. Then there's latency. Physical reactions need to happen in under 10 milliseconds. Trip, and you need to catch yourself now, not 50 milliseconds from now. General-purpose chips add overhead that robots can't afford. And finally, cost. If you're building a billion robots, even $50 savings per chip equals $50 billion. At that scale, custom silicon isn't a luxury, it's survival. Last month, Tesla, SpaceX, and xAI announced Terrafab, a joint chip fabrication facility in Austin, Texas. This isn't a partnership with an existing fab. They're building their own. Terrafab will produce two types of chips. First, an edge inference chip optimized for Optimus robots and Tesla vehicles. This chip runs the neural policies that control walking, grasping, and navigation. It's designed specifically for the power envelope and thermal constraints of a robot body. Second, a space-hardened chip for orbital compute. Radiation-tolerant, capable of operating from -150 to +120 Celsius, and built to run for years without any possibility of service. The scale target is staggering. Terrafab aims to produce 1 terawatt of AI compute per year. For context, all existing fabs combined, TSMC, Samsung, Intel, currently produce about 20 gigawatts of AI compute annually. Terrafab's target is 50 times that. Musk put it bluntly. Everything that exists today represents maybe 2% of what they're planning. The real innovation at Terrafab isn't a chip design, it's the chip-to-mask loop. Here's how chips normally get made. A company in California designs a processor. They send that design file to TSMC in Taiwan. TSMC makes the lithography masks, the stencils used to etch circuits onto silicon, at one facility. They fabricate wafers at another. They package the chips somewhere else entirely, maybe Malaysia or Vietnam. 3 to 6 months later, test chips finally arrive back in California. The engineers find bugs. They iterate on the design, and the entire cycle starts over. A single chip can take 18 to 24 months and 3 to 5 complete cycles before it's ready for production. Terrafab puts everything under one roof: mask making, wafer fabrication, packaging, and testing, all in the same building as the design team. The goal is radical. Monday, design change. Friday, chips on the test bench. Weekend analysis. Monday, redesign. Think of it like this. The old model is sending letters across an ocean and waiting months for replies. The new model is walking down the hall. If Tesla achieves 50 iteration cycles per year, while competitors relying on TSMC get 1 or 2, the compounding advantage is devastating. Each cycle produces a smarter, more efficient chip. By year 3, competitors aren't just behind, they're playing a different game. And for Optimus, every 6-month advantage in chip development means another generation of robot intelligence, while everyone else is still waiting for their test wafers. Let's talk numbers, because the scale here is hard to process. Current global AI compute output, everything TSMC, Samsung, and Intel produce combined, totals roughly 20 gigawatts per year. Terrafab's target is 1 terawatt. That's 50 times the entire world's current AI chip production. From a single facility. Then there's the robot number. Musk said he expects humanoid robot production to reach somewhere between 1 and 10 billion units per year. To put that in perspective, global car production is about 100 million vehicles annually. Even the low end of Musk's range is 10 times the entire automotive industry. This isn't a robotics company scaling up production. This is a civilization-scale manufacturing thesis. And the chip is the bottleneck. You cannot build a billion robots if you're waiting in line at TSMC behind Apple and Nvidia and Qualcomm and everyone else. Terrafab is the attempt to remove that constraint entirely. Now let's talk about that second chip, the space-hardened one, because it reveals something bigger. Ground-based AI compute is hitting physical limits. Solar power on Earth's surface delivers maybe 200 to 250 watts per square meter, after you account for atmosphere, weather, and the fact that it's dark half the time. Data centers need massive cooling systems. Transmission lines lose power over distance. Space is different. Solar intensity in orbit is 1.4 kilowatts per square meter. No atmosphere absorbing energy. Position your panels correctly, and you get sunlight 24/7. No clouds, no seasons. And cooling? You radiate heat directly into the vacuum of space. It's free. Musk's prediction: within 2 to 3 years, running AI compute in orbit will be cheaper than running it on the ground. The space-hardened chip makes this possible. It needs to survive cosmic radiation. Temperature swings from negative 150 to positive 120 Celsius, and years of operation with zero possibility of maintenance. Here's where it connects back to humanoid robotics. If space compute becomes cheaper than terrestrial, the brains running your robots might not be in the robots. They might not even be on the planet. Inference could happen in orbit, with results beamed down at light speed. The robot becomes a body piloted by a brain in the sky. If vertical integration is so powerful, why hasn't anyone else done it? Because it's insanely hard. Building a semiconductor fab costs $10 to $20 billion and takes 5 or more years to reach competitive yields. The expertise required is so specialized that TSMC has spent 3 decades perfecting processes that competitors still can't match. In the 1980s and 90s, the chip industry figured out it made sense to separate design from manufacturing. AMD designs chips. Qualcomm designs chips. Apple designs chips. TSMC manufactures them. This fabless model became standard because almost no one could afford to do both. Terrafab is a bet that vertical integration makes sense again, but only if you have 3 things: the capital to spend tens of billions, the volume to justify a dedicated fab, and a specific workload that doesn't change shape every product cycle. Tesla arguably has all 3. Market cap over 100 billion, a billion Optimus units as the demand thesis, and neural policy inference for walking robots. A workload that will look roughly the same whether it's running in 2025 or 23. That stability is what makes custom silicon viable. Here's where the competitive dynamics get brutal. Every other humanoid robot company, Figure AI, Agility Robotics, Unitree, Boston Dynamics, runs inference on off-the-shelf silicon right now. That means paying NVIDIA's margins. It means fitting your robot's intelligence budget to a chip designed for someone else's use case. And it means watching Tesla get 50 chip iterations per year while you get 1. Custom silicon is a structural advantage that compounds. Each iteration cycle, Tesla's chip gets more efficient. Their robot runs longer, reacts faster, costs less. The gap widens every quarter. The analogy is Apple's switch to M1 processors. When Apple stopped using Intel chips and started designing their own, it didn't just make MacBooks faster, it made the entire Intel-based laptop industry look like it was running in quicksand. Competitors weren't worse at engineering, the game had fundamentally changed. Tesla is attempting the same structural shift in robotics. And the question no one can answer yet: will Terrafab sell chips to competitors, or is this advantage staying captive? This isn't about Tesla winning a chip race. It's about whether the infrastructure for a billion robot world gets built inside one company's walls, or gets competed over in the open market. That question will shape the next 50 years of how humans and machines share the planet.